Today, we're going to talk about reactions of acids and bases. I hope you remember from Chem 2 that acid-base reactions are a type of double replacement reaction. We called these acid-base reactions. Our XN stands for reaction, or we called them neutralization reactions. What you may remember from the naming acids unit is that if you have an H with some sort of anion, that's an acid, is when you have something with an OH, it's a base. And if we remember, this OH is actually OH minus, and we call that hydroxide. So the general equation is we have H with some sort of anion, aqueous, plus some sort of cation with OH, also aqueous in this case, and we're going to make water, which is always a product of a neutralization reaction. I'm going to write it as HOH, plus your cation, anion, aqueous, salt. So to recap, we have an acid because of the H, plus we have a base because of the OH minus, and they react to give us water, and a salt. And remember that a salt is any ionic compound. So I want you to consider the reaction of hydrochloric acid with potassium hydroxide. So if you remember, if you want to answer these questions more robustly, you'll start by identifying ions. If it's hydrochloric acid, that means you must have an H plus because it's an acid, and hydro blank ic acid, remind you that you have the IDE ending for chloride, so you should have Cl minus. And then potassium ions are K plus if you refer to your periodic table. And then hydroxide, you should now know, is OH minus. Lucky for us, all the charges are 1, so they'll come together in a 1-to-1 fashion to get HCl, aqueous, plus KOH, also aqueous. If you're wondering why these are written as aqueous, you can review your solubility notes from Chem 2. In our classic double replacement fashion, what we're going to do is we're going to take our first cation and swap partners with the second anion. So that's going to give us our HOH, which is our water. And then we're going to combine the other two, which is just going to be KCl, aqueous. And because all of these charges are 1, they all come together 1-to-1. So the next thing you want to do is you want to check, make sure that everything's balanced. Excellent. Next, it asks us what the net ionic equation is. If you remember, the thing that we did before a net ionic equation was a complete ionic equation. And that's when we basically just rewrite the molecular equation, but with all of its ions. The H in HCl is going to be H plus, aqueous, plus Cl minus, aqueous. We just got one of each of those, plus K plus, aqueous, plus OH minus, aqueous. And remember that the reason why all of these are aqueous, it's rewriting the molecular equation. So if our molecular equation says that it's aqueous, our complete ionic equation will state that it is also aqueous. If you remember, we keep our H2O or our HOH as a liquid, does not break apart in solution. Cl minus, aqueous. And then if you think back and you review your notes, you'll remember that the difference between a complete ionic equation and a net ionic equation is that the net ionic equation removes spectator ions. Net ionic equations will include whatever phase is not aqueous. So H plus OH minus, aqueous, gives us H2O, liquid, or you can write it as HOH, liquid. Since we are talking about neutralization reactions, our net ionic equation will actually always remain the same, which is very cool. All right, what I want you to do right now is I want you to do this understanding check. I want you to take a moment, I want you to pause the video, and I want you to solve this problem. Okay, welcome back. Phosphoric acid. Acid means we have H plus as our cation, and then ic acid means that this must be phosphate. Hopefully what you remember is that phosphate is PO4 3 minus. Sodium hydroxide, we're going to have Na plus and OH minus. So now that we have all of our ion components, we can put them together to form our molecular equation. So H3PO4, aqueous, plus NaOH, also aqueous, gives us HOH, liquid, plus Na3PO4, aqueous. All right, now that we have written down all of our compounds as formula units, we now have to balance our equation. So we have 3 H's here, and we have 1 here. We're going to make that a 3, which means we need 3 OH's, which gives us 3 NA's, but there are 3 NA's here. So we are good to go. We're all balanced. So now that we have this balance, we can write our complete ionic equation. So there are 3 H pluses, aqueous, plus PO4, 3 minus, aqueous, plus 3 Na plus, aqueous, plus 3 OH minus, aqueous, gives us 3 H2O, liquid, plus 3 Na plus, aqueous, plus PO4, 3 minus, aqueous. And remember that the difference between the two is that we now must get rid of our spectator ions. We have 3 Na pluses on both sides. We have PO4, 3 minus on both sides. And what we get is 3 H plus 3 OH minus gives us 3 H2O. But we can simplify that, get rid of our 3's, and our answer just becomes, great. On to page 2. If we react an acid with an active metal, what we have is a single replacement reaction. And remember that we can identify single replacement reactions because we're reacting with an element. So what this looks like is we have our acid, aqueous, plus a metal, gives us our metal with our anion plus H2 gas. Solid and anionic compound that's likely soluble. And so what we're reacting is an acid plus a metal, which gives us a salt plus hydrogen gas. And you'll notice that this reaction actually is not balanced. So we have 2 H's, which means we have 2 A's, which means we have 2 metals. Okay, so sulfuric acid means we're going to be working with H plus, and sulfuric means sulfate, SO4, 2 minus. And we're just going to write down what zinc would be as an ion. And you may remember this is an exception that always has a charge of +2. So if we put these together, we're going to have H2SO4 aqueous plus zinc as a metal, right? We're reacting the metal first. And then we're going to have our products of ZnSO4 +2 -2. So they come together 1 to 1, aqueous, and H2 gas. All right. I want you to do the next one. I want you to take another moment where you briefly pause, fill this out, and then compare with my answer in the video. So what I hope you started with was your ions. So we have nitric acid, which means that we have H plus, and nitric means it must be nitrate, which should be NO3 minus, with magnesium, which would make Mg2 plus if it was an ion. Putting them all together, we have nitric acid, HNO3, aqueous, plus magnesium. So magnesium is a solid, is a metal, and it will switch partners. So we'll get MgNO3 2, because we have our 2 plus and our minus. This is going to be aqueous, plus H2 gas. Once again, we have our H2 gas. Now we have another type of acid reaction with oxides, carbonates, and sulfides. And so I want you to practice writing out these solutions. Then I will put up the answers and you can identify what you missed. All right, for the first one, I hope that you remembered all your ions and that you remembered to balance your equation. So what you should have seen is hydrochloric acid would be H plus Cl minus, and calcium oxide would be Ca2 plus and O2 minus. For this one, I hope that you remembered all your ions again, just to be thorough. We have H plus, Br minus, Ca2 plus, CO3 2 minus. And I'm hoping that H2CO3 reminded you of something, and that's that this actually is unstable and that it becomes H2O liquid plus CO2 gas. All right, and for this last one, I hope you remembered that H2S is gas. If you don't remember them, look back at your Chem 2 notes, but there are a couple double replacement reactions where they are gas forming, and so then you have to remember NH4OH is one of these, H2CO3, H2SO3, and H2S. This one actually is a gas. These three are unstable. And I'll let you look back in your notes to figure out exactly what happens with all of these.